Hi all, welcome back to HEAT Part 2 and is about thermal expansion. What is mean by thermal expansion? It is the change in dimension of a body accompanying a change in temperature. State three types of thermal expansion. First is about linear expansion, followed by area expansion, and finally is about volume expansion. Describe the thermal expansion in solid, liquid, and gas. In solid, all types of thermal expansion occur. In liquid and gas, only volume expansion is occur. At the same temperature, the gas expands greater than liquid and solid. Let us see linear expansion. Consider a tin rod of initial length L0 at temperature T0 is heated to a new uniform temperature T and acquires length L. Once we heat up the rod will expand, and you can see the change in length of del L, and you can see the change in temperature from T0 to T. Therefore, the change in length is directly proportional to the change in temperature, and change in length directly proportional to the original length of the rod. If the change in temperature is not too large or less in 100 degrees Celsius, so we will get one solid mathematical equation which is change of length directly proportional to the original length of the rod and directly proportional to the change in temperature. Once we break the proportionality terms into equation, it forms one constant value, so called alpha. This alpha is coefficient of linear expansion. Different materials have different coefficient of linear expansion. Change in length is final length of the rod minus the initial length of the rod. Change in temperature is final temperature minus the initial temperature. Now define coefficient of linear expansion, which del L equals to alpha times L0 times del T. Alpha is coefficient of linear expansion, del L is change in length, del T is change in temperature, L0 is original length. Or coefficient of linear expansion is defined as the change in length per unit length or original length per unit rise in temperature. The unit for coefficient of linear expansion is per degree Celsius or per Kelvin. Let us try to attempt this A-level question. A rod 3.0 meter long is found to have expanded 0.091 cm in length after temperature rise of 60 degrees Celsius. What is the coefficient of linear expansion for the material of the rod? The final answer is 5.06 times 10 to the power of negative 6 per degree Celsius. So by using the equation of change in length equals to alpha times L0 times change in temperature, the change in length is 0.091 centimeter. We can substitute here, but have to change to meter by times 10 to the power negative 2. With the original length is 3.0 meter and the temperature change or rise is 60 degrees Celsius. You can put it here. So the coefficient of linear expansion is 5.06 times 10 to the power negative 6 per degree Celsius. Simple like a bubble without giving you any trouble. Or we can put the temperature into Kelvin by plus 273. 60 degrees Celsius plus 273, and your coefficient linear expansion now is 9.11 times 10 to the power of -7 per Kelvin. So you have two options. One, put it in per degree Celsius or into per Kelvin. Let us try to attempt another A-level question. The length of a copper rod is 2.001 meter and the length of wolfram rod is 2.003 meter at the same temperature. Calculate the change in temperature so that the two rods have the same length where the final temperature for both rods is equal. Given the coefficient of linear expansion for copper is 1.7 times 10 to the power of -5 per degree Celsius and the coefficient of linear expansion for wolfram is 0.43 times 10 to the power of -5 per degree Celsius, and the final answer is 78.73 degrees Celsius. According to the questions, the length of copper equals to length of wolfram. By using the formula of change in length equals to alpha times L naught times del T, alpha is coefficient of linear expansion, you will get the equation in this form. When you expand this, you will get this. And we're going to use this equation to solve this problem. So when the length of copper equals to length of wolfram, you're going to substitute all the values accordingly on both sides of copper and wolfram to get the final answer, which is the change in temperature is 78.73 degrees Celsius. Make sure your algebra is not algebra. If you well substitute all the values into this equation, definitely you will get this answer. Thank you for watching this video. Thanks a lot and thank you to the Lord.